Hello everyone. For this week's experiment, I am going to be showing you why heavy things like boats float and why little tiny objects like pebbles sink to the bottom of the sea. For this experiment, I'll be needing a walk as my ocean and this ball as my ship. And we also have a couple of passengers over here.
All, we need to be aware of the two types of forces. Firstly, the force of gravity, which as we all know pulls objects downwards and is measured as its weight. On the other hand, there's a force called buoyancy, which is the force with which any liquid pushes objects upwards when placed in it. This buoyant force is equal to the weight of the liquid that was pushed away when the object was placed on it. Whether any object will float or sink depends on which of these forces is greater. If the weight of the object is more than the buoyancy of the object, then it will float, as the upward push on it is more than the downward pull. If, however, gravity is pulling down with greater weight than the buoyancy is pushing up the object, then the object will sink. We all know that metal is heavier than water, and this is why it sinks when I place it inside the water in the first place. Here, it has displaced a tiny amount of water, only as thin as the metal it is made up of. The weight of this tiny amount of water is much less than the weight of the ball itself. Thus, gravity wins against buoyancy, pulling the ball down to the bottom. Next, I place the ball flat on the surface of the water. This time, it is pushing away a lot of water in the shape of itself, and this space is being taken by the bottom of the bowl containing air on the inside. The weight of this large amount of water that was pushed away is much more than the weight of the empty bowl. This is why the buoyancy of the bowl pushing it up is greater than its weight, and the bowl floats easily on the water. As you see now, even if I put a few passengers in my ship, it is still floating. But the moment the weight of the ship and its passengers will become more than its buoyancy, the ship will sink to the bottom of the ocean. Also, if the boat develops a leak, water will rush in it and take up the space inside the bowl, which was so far being filled with air. Now the weight of the boat full of water will be much more than the weight of the water displaced only by the empty boat itself, and again the boat will sink to the bottom of the ocean.
Enough of experimenting now. Time for some fun facts. Let's get rid of all this. And this time we'll need a needle, a plate, and some water. Okay, I'm now going to pour this water in very carefully. Now I'm going to place this into the water, and you'll find that it is sinking. This is because the metal is way heavier than the water. Now I will slowly place this needle into the water by sliding it along here, and we'll see what happens now. Now, as you can see, this needle is perfectly floating on top of the water. I'm just going to play around with it now. Now, I'll show you what happens when I push it inside. Sinks. As you saw just there is also another force called surface tension, which can make a heavier object float on the water. However, if we very gently slide the needle into the water from the side, it did float freely. This is because of the force of surface tension, which behaves like a sheet stretched tightly on the surface of the water. Now, when we push the needle at one end, it then makes a hole in this imaginary sheet and again sinks to the bottom. Thank you for watching.